Welcome. This is CIE 9709, Paper 5, Probability and Statistics 1 of May-June 2022, Paper 51. So we shall start to solve the question paper. Question number 1. Find the number of different arrangements. This is arrangements, so it belongs to permutations of the 8-letter words deceived. Deceived, D-E-C-E-I-V-E-D. 8-letter words are there, in which all three E's come together. So these three E's are together and they are tied and they become one unit. And two D's together. Two D's are also tied together and become one unit. So two D's are over and three E's are over. So what am I left over with? C-I-V. So totally how many units? This is one unit, this is one, and this is one. Totally how many units are there? 5 units are there. These 5 units can be arranged in how many factorial? 5 factorial. So 5 units arranged in 5 factorial ways. Find the number of different arrangements of the 8-letter word in the word deceived, in which all threes are not together. So first of all, I will be finding total number of ways. Total number of ways is 8 factorial, and there are divided by 2 factorial and 3 factorial. Why am I dividing it out? Because these are 2 D's and 3 E's. Whenever they are similar, you divide them. So answer is 3360. Now 3 E's are not together. All the 3 E's are not together. So what am I going to do with 3 E's together? 3 E's together. So it will be all the 3 E's tied it as one unit. One unit. Then I'll be left over with D, D, C, I, V. So it is 1, 2, 3, 4, 5, 6. 6 units. It is going to be how much? 6 units. All E's together. So this is going to be 6 units. 6 units can be arranged among themselves in how many ways? 6 factorial divided by 2 factorial. This 2 factorial is for D's. This is going to be nothing almost 360. So with 3 E's not together. 3 E's not together will be total minus E's together. Total minus E's together will be 3 E's not together. So 3360 minus 360. So which is going to be 3000. That's going to be the answer. Question number 2. There are 6 men and 8 women in a book club. How many men are there? 6 men. How many women are there? 8 men. So 6 men, 8 women are there. The committee of a club consists of 5 of its members. Mr. Lan and Mrs. Lan are the members of the club. In how many different ways can a committee be selected if one of Mr. Lan and Mrs. Lan must be in the committee? A committee consists of 5 members. So totally I have to select it out 5. So how should I be able to select that one? If one of them is Mr. Lan or Mrs. Lan, one of them should be there. So if Mrs. Lan is already there, so already what is this? 6 will become 7. Then Mr. Lan should not be there. So this will become 5. So what is this case? Lan, Mr. Lan not there, and Mrs. Lan present. So how many people are left over? Now 7 plus 5, 12. So it is 12, and I have to select, because out of 5, 1 has been selected. So 11, 12C, 4. That is one of the way. If Mr. Lan is not there and Mrs. Lan is present. Next time, again, I have 6 men and 8 women. Now this time, Mr. Lan is present. So 5 will become, so Mr. Lan and Mrs. Lan is not present. 8 will become 7, Mrs. Lan. So what is that again? This is 5 members. 5 members, one more 4 members only are to be selected. What is this one? Mr. Lan present and Mrs. Lan not present. So again it is going to be nothing but what? 12C, 4. 5 plus 7 is 12 and 12C, 4. So total answer is going to be nothing but what? Final answer 12C4 plus 12C4. So which is going to be 990. That is the answer. In how many different ways can the committee be selected if Mrs. Lan must be on the committee and there must be more women than men? So men is 6 and woman is 8, and I should have always totally 5 members. Now Mrs. Lan must be on the committee. Mrs. Lan should be there on the committee. So this 8 becomes 7, 5 becomes 4. So Mrs. Lan should be on committee. So Mrs. Lan is already selected. So I have 7 women and 6 men, and there must be more women than men. There must be more women than men. So if at all 2 women, 2 men. So because 2 plus 1, this is already 3 women. Because 1 woman is already selected. 1 woman is already selected. So I will be having it at 3 women, 2 women and 1 man. And similarly 3 women and 1 man. And 4 women and 0. So this is going to be the answer. So what does that becomes now? 6C2 times 7C2 plus 6C1 times 7C3 plus 6C0 times 7C4, which is 315 plus 210 plus 35, which is going to be 560. Question number 3. The times taken to travel to college by 2,500 students are summarized below. Draw the histogram for this. So, first of all, we have to calculate the frequency density. For calculating the frequency density, we will be calculating the class width. Class width is 0 to 20 is 20, 20 to 30 is 10, 30 to 40 is 10, 40 to 60 is 20, 60 to 90 is 30. Then I'll be calculating frequency density. What is the formula for frequency density? Which is frequency divided by class width. So 440 divided by 20, 720 divided by 10, 920 divided by 10, 300 divided by 20, 120 divided by 30. So this is going to be giving me the class width as 22, 72, 92, 15 and 44. 15 and 4 is going to be the class width. So my least number is 4, highest number is 92. So frequency density should be there on the y-axis and time should be on the x-axis. So time taken in t minutes. So don't forget to write the units and the frequency density. Frequency density on x-axis. Now If I take each line as 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. So you can see that the gap is 5 and there are 5 units. Gap equals to 10 and number of parts. Number of parts is 5. So each part is going to be 10 divided by 5, which is 2. So this is 2, this is 4, this is 6, this is 8 and this is 10. Same is the case, this is 12, this is 14, this is 16 and so on. In that way we will be getting it out all the values. Each line is going to be 2 units. That is going to be the way. Now for time. Time also I am going to take the same 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Here also we can see that 5 gaps are there. 1, 2, 3, 4, 5 parts are there. And what it says for that also I can see the gap is 10 and the parts equals to 5. So each part is going to be 10 divided by 5, which is 2. Now I am going to do the graph. For 0 to 20, the frequency is 22. 0 to 20, it's going to be 22. 22 from 0 to 20. Then from 20 to 30, it is 72. 20 to 30, it is going to be 72. 20 to 30. Then 30 to 40, it is 92. 30 to 40, it is 92. Then 40 to 60 is 15. 40 to 50 is 16. 40 to 60 is 16. And finally 60 to 90 is 4. 60 to 90 is 4. This is going to be the frequency density drawn on histogram. From the data, estimate the mean value of t is 31.4. Calculate the estimate of standard deviation and the times taken to travel. So for that, I have to calculate the midpoints. I have to calculate midpoints. Midpoints is 0 plus 20 divided by 2, which is 10. Then 20 plus 30 divided by 2, which is 25. Then the next one is 30 plus 40. 30 plus 40 divided by 2, which is 35. Then 40 plus 60 divided by 2, which is 50. Then 60 plus 90 divided by 2, which is 75. Now the mean is given as 31.44. So calculate the standard deviation. So variance, I am going to calculate the variance, which is 440 times 10 square plus 720 times 25 square plus 920 times 35 square plus 300 times 50 square plus 120 times 75 square, total divided by 2500 minus, don't forget to do minus, so this total, then minus mean square 31.44 whole square. Simplify that, you should be getting 229.9264. This is variance. is asking standard deviation, which is square root of 229.9262, which is going to be nothing but how much? 15.2 is going to be the answer. 15.2. In which class interval does the upper quartile range lie? Upper quartile, so 2500 divided by, what is this? 4 times 3, which is going to be nothing but how much? 7500 divided by 4. 7500 divided by 4, which gives me 1875. So now we have to do the cumulative frequency. So I'm going to find the cumulative frequency. Till here 440. 440 plus 720 is 1160, plus this one is going to be 2080. So I want 1875. So it lies between 30 to 40. It lies between 30 to 40. It was later discovered that the times taken to travel to college by two students were incorrectly recorded. One student time was 15 instead of 5, so there was an increase of 10. Another student was recorded 65 instead of 75. So this is minus 10. So, without doing any further calculation, state with a reason whether the estimated standard deviation would be increased or decreased. Standard deviation will not change for additions or subtractions. Standard deviation will not change for additions or subtraction. So therefore, it will remain same, stays the same. Stays the same. Question number 4. Jacob has 4 coins. One of the coins is biased in such a way that when it is thrown, the probability of obtaining head is 7 upon 10. The other 3 coins are fair. Jacob throws all 4 coins at once. The number of heads that he obtains is denoted by x. Find the probability distribution is this one. Show that A equals to this one. So A, what is A? A is probability of one head. Probability of one head. So I have to get it on one head. How can I get that one head? He has 4 coins. 1, 2, 3, 4. 4 coins are there. This coin is head and tail, tail and tail. Then this is tail, head, tail and tail. Tail, tail, head, tail. Tail, tail, tail and head. So for this, what is this? For the first coin, probability of head is 0.7 and tail is 0.3. For second coin and third coin and the fourth coin, for all these 3 coins, probability of head is 0.5 and tail is 0.5. So for this case, what does it become? 0.7 times 0.5 whole cube. For this will become 0.3 times 0.5 times 0.5 whole square. For this one, it becomes 0.3 times 0.5 times 0.5 times 0.5, and for this one 0.3 times 0.5 times 0.5 times 0.5. So what's going to be that answer? 0.7 times 0.5 whole cube plus 0.3 times 0.5 whole cube times 3. This is going to be the answer, 1 upon 5. So A value is 1 upon 5. Now find the expected and hence find the values of B and C. We have to calculate the values of B and C. B is 2 heads and C is 3 heads. So Now I have to get it out. Probability of, what is this? 2 heads. 2 heads means it should be head head and tail tail. Then this is somewhat difficult to do. So rather than what I will be doing it out, I will do first C. 3 heads. If at all I do C, then it is easy to do B. 3 heads. So what am I going to do? Head, head, head and tail. Head, head, tail and head. Then head, tail, head, head. And tail, head, head, head. So like that I'm going to get it out 4 ways. So for this one, it's going to be 0.7 times 0.5 whole to the power of 3. For this one also 0.7 times 0.5 whole to the power of 3. For this one also 0.7 times 0.5 whole to the power of 3. For this one it is 0.3 times 0.5 whole to the power of 3. So when I add it at all, so I am going to get this one as 3 upon 10. So C value is 3 upon 10. So what will be the B value? 3 upon 80 plus 1 upon 5 plus B plus 3 upon 10 plus 7 upon 80 equals to 1. Sum of all values. So from here, B value, use the calculator, you should be getting 3 upon 8. That's going to be the answer. Hence find the expected value. So what am I going to do? I am going to draw this copied on this table over here to get the expected value. So expected value of x will be 0 times 3 upon 80 plus 1 times 1 upon 5 plus 2 times 3 upon 8 plus 3 times 3 upon 10 plus 4 times 7 upon 80. So simplify that, which is 176 upon 80 or 2.2. Jacob throws all 4 coins together at 10 times. Find the probability that is obtained exactly 1 head on fewer than 3 occasions. So what is this? Exactly 1 head. So probability of getting 1 head. What is the probability of getting 1 head? What was that? 1 upon 5, which is 0.2. 0.2, this is the success. So failure is going to be nothing but what? 0.8. Now fewer than 3 occasions on 10 occasions. So it can be 10C0 or 10C1 or 10C2. So over here, success should be 0 times and failure should be 10 times. Success should be 1 time, failure should be remaining 9 times. Success should be 2 times and failure should be remaining 8 times. Simplify this, you should be getting that answer as 0.107374 plus 0.268435 plus 0.301989, which should be the answer 0.678. Find the probability that Jacob obtains exactly 1 head for the first time on the 7th and 8th time of the throw that he has throws in the 4 coins. So he should be getting the 7th time or 8th time. When he is getting for the 7th time means 6 times he is getting tail, and 7th time he should be getting a head. So 6 times tail is 0.8 whole to the power of 6. Then 7th time head is 0.2. Whereas over here 8th time means 7 times tail and 8th time is going to be head. 7 times tail is 0.8 whole to the power of 7. 8th time head is 0.2. 8th time head. So, and then add them up, which is going to be the answer 0.0944. Question number 5. The lengths in centimeters of the leaves of a particular type are modeled by the distribution. Find the probability that a randomly chosen leaf of this type has a less than 6 centimeters. So, mean equals to 5.2 and standard deviation equals to 1.5. So, probability of x less than 6. First step is convert into z. So, z less than 6 minus mu upon sigma. The formula is x minus mu upon sigma. So probability of z less than 0.5333. See the table, you should be getting 0.703. The lengths of the leaves of another type are modeled by normal distribution. A scientist measured the random sample of 500 leaves. 46 are less than 3 centimeters long. Probability of x less than 3 centimeters equals to how many as 46. 46 upon 500. So probability of z less than 3 minus mu upon sigma equals to, what am I going to do? I am going to do 46 divided by 500, which is going to be 0.092. But 0.092 will not be there in the table. So minus 1 minus that, which gives me 0.908. So whenever I'm doing that one, I am going to swap this one, mu minus 3 upon sigma. Whenever I do 1 minus, I need to swap it out this one. Now see in the table, mu minus 3 upon sigma in the table, when I do see it out 0.908, it's going to be 1.329. Check that value from the table, it should be 1.329. Similarly, next one, more than 8 centimeters long. So probability of x greater than 8 equals to 95 upon 500. So 95 upon 500 is again 0.19. So convert z greater than 8 minus mu by sigma equals to 0.19. Converting to greater to lesser than is 1 minus probability of z less than 8 minus mu by sigma equals to 0.19. Probability of z less than 8 minus mu by sigma equals to 0.81. 8 minus mu by sigma equals to, from the table, see that 0.878. Now what am I going to do? I am going to divide both. Mu minus 3 by sigma divided by 8 minus mu by sigma equals to 1.329 by 0.878. Sigma sigma cancels, then do the cross multiplication. So 0.878 mu minus 3 times 0.878 equals to 1.329 times 8 minus 1.329 mu. Then 0.878 mu plus 1.329 mu equals to 1.329 times 8 plus 3 times 0.878. So therefore mu will be equals to 1.329 times 8 plus 3 times 0.878 divided by 0.878 plus 1.329. Simplify that, you should be getting 2.27. Now substitute this value of mu in one of the equation. So it's going to be, I'm going to substitute in this one. So 2.27 minus 3. So I got the value of mu as 6.01. It's not 2.27. We should be getting this value as 6.01. So I substitute that value of mu. I'll be getting 6.01 minus 3 by sigma equals to 1.329. From here sigma value will be getting it as 2.27. In a random sample of 2000 leaves, of the second type, how many the scientist would expect to find the lengths more than one standard deviation of the mean. Probability of x greater than one standard deviation. Lengths more than one standard deviations from the mean. So it can be, what is that? If this is a graph and this is the graph, over here it is one standard deviation and over here it is one standard deviation. So it can be two ways. Probability of x less than one standard deviation. One standard deviation is one standard deviation from the mean. So less than, this value will be 6.01 minus 1 times 2.27. This value is going to be 6.01 plus 1 times 2.27. Is asking how many would you expect with the lengths more than. So I have to find it out, this area. So probability of x less than, this becomes 6.01 minus 2.27. It's going to be 3.74, less than 3.74, and this area is probability of x greater than 8.28. So probability of z less than 3.74 minus 6.01 divided by 2.27. This is probability of z less than -1. This is probability of z greater than 8.28 minus 6.01 divided by 2.27. This is probability of z greater than 1. So 1 minus probability of z less than 1. So this is negative. So 1 minus probability of z less than 1 plus 1 minus probability of z less than 1. Converting negative to positive, converting greater than to lesser than. So this is going to be 2 minus probability of z less than 1. So which is 2 times. 2 minus 2 times 0.8413, which is going to be 0.3174. Question number 6. Janice is playing a computer game. She has to complete level 1 and level 2 to finish the game. She is allowed at most 2 attempts at any level. For the level 1, the probability that Janice completes it at first attempt is 0.6. She fails at the second attempt. At first attempt, the probability that she completes the second attempt is 0.3. If Janet completes the level 1, she moves to the level 2. For level 2, probability of first attempt is 0.4, and failing the first attempt, probability she completes it at the second attempt is 0.2. Show that the probability that Janice moves to the level 2 is 0.72. So how can she move to the, what is this? So first attempt, she passes, so 0.6. Now she passes at the second attempt, means first attempt has been failed and second attempt she has passed. First attempt has been failed is nothing but how much? 0.4 times second attempt she passes is going to be nothing but second attempt she completes it at the second attempt is 0.3. So add them both, which is going to be 0.72. Find the probability that Janet finishes the game. So she can finish at the first attempt or she can finish at the second attempt. She can finish at the first attempt or she finishes the game. She finishes the game level 1 and what it says, she finishes the level 2. So what is that being done over here? For level 1, the probability that she completes at the first attempt is 0.6. She fails the attempt, and the probability that she completes it at the second attempt is 0.3. So she completes the first level. First level completion is already 0.72. Now for the second level. Come to the second level. She completes in the first attempt is 0.4. She can complete in the first attempt is 0.4, or she can complete in the second attempt. Means what happened to the first attempt? First attempt she has failed. Then second attempt she has passed. Second attempt she has passed. So first attempt she has failed is, what is the failing of the first attempt? If passing of first attempt is 0.4, so failing of the first attempt is going to be 0.6. Passing at the second attempt. Passing at the second attempt is nothing but what? 0.2 times 0.2, or means plus. So do this one, 0.7 times this one, and so on. So 0.72 times 0.4 plus 0.6 times 0.2, which is 0.3744. This is somewhat confusing, so see 2 or 3 times before proceeding to the next question. Find the probability that Janice fails exactly one attempt given that she finishes the game. So fails first given that finishes the game. So it's going to be probability of fails first intersection finishes divided by probability of finishes. Probability of finishes was we have already got it out, 0.72 plus 0.72 times 0.4 plus 0.6 times 0.2. Now she fails in the first. She fails in the first attempt. So which one is fails in the first attempt? This one is failing in the first attempt, and she's failing in the first attempt. She fails in the first attempt, here first or second. She fails in the first or second. She fails one attempt. One attempt means it can be either be first attempt or second attempt. She fails first attempt or second attempt. And what is this? She finishes the game. She fails in the first attempt or the second attempt. So coming to the level 1. So see carefully over here. This is most confusing question. So you have to be very much clear over here. For level 1, probability that Janice completes it at the first attempt is 0.6. If she fails at her first attempt, the probability that she completes it at the second attempt is 0.3. So what am I going to do that? What is this? She will be failing in the first or the second level. First level or the second level. And probability that this is for level 1. After level 1, what is happening? She is moving to level 2. For level 2, the probability that Janice completes it at the first attempt is 0.4. So if at all I draw a tree diagram, then it will be much more easy to understand. So let me try to draw the tree diagram for this. So over here, this question is very easy to understand if I draw a tree diagram. So level 1. Level 1. Probability of success is going to be 0.6. So failure is going to be 0.4. Then if she fails in the first attempt, the probability that she completes in this is for level 1. If she fails, then to complete the game is second attempt is again success is 0.3 and failure is going to be 0.7. Now this is for nothing but what? Level 1. Now this happened in level 1. Now she comes to level 2. Now she passes the level 1, so that she comes to level 2. The success she completes this one in the first attempt is going to be 0.4. So failure is going to be nothing but what? 0.6. Now again, she plays. When can she play the level 2? Whenever she passes the first attempt. So over here. So for this, if she fails her first attempt, now for again, after passing, probability of this one is 0.4 and 0.6. Now if she fails her first attempt in the level 2, she completes it in the second attempt. If she fails in the second attempt, passing is 0.2. Failing is going to be 0.8. Now again, passing is 0.2 and failing is 0.8. Now that is the case of drawing the tree diagram. Now what is being asked in the question? In the question it is asked, if she fails exactly in one of the attempt. She has to fail in exactly one of the attempt. So she can fail in the first attempt or in the second attempt, but she finishes. So it can be in this way, 0.6, 0.6 and 0.6, in which way she failed in one of the attempt. Or else it can be she fails in one of the attempts. So it can be 0.3, 0.4 and 0.4. 0.3, 0.3 and 0.4, where you can see that she fails in exactly one of the attempt. So that goes to the numerator. 0.6 times 0.6 times 0.2 plus 0.4 times 0.3 times 0.4. That's going to be the answer, which is 0.321. She either fails first attempt or the what is this? She fails in the second attempt. She fails the first level, or she fails first level or second level. That's going to be the answer, 0.321. That completes this paper. See you in the next paper. Bye.